Every year, humanity cuts down billions of trees to build homes, furniture, floors, and cities. Forests that took decades, even centuries to grow, disappear in months. Yet hidden in plain sight is a plant that grows faster than almost anything on Earth, regenerates naturally without replanting, and can be transformed into a material stronger than many hardwoods. That plant is bamboo. This is the story of the supergiant bamboo wood factory, where fast-growing grass becomes one of the strongest building materials of the modern world. Before we step inside this remarkable green industrial system, don't forget to like this video, subscribe, and turn on the notification bell so you never miss our deep dive documentaries into the hidden industries shaping the future of construction and manufacturing. Bamboo has been used by humans for over 5,000 years. Ancient civilizations across Asia, Africa, and South America relied on bamboo for housing, tools, bridges, furniture, baskets, and even weapons. Entire villages were built from bamboo. But for most of history, bamboo was limited by its natural form. It was lightweight, flexible, and renewable, but not always strong enough for modern construction demands. The turning point came with industrial engineering. As deforestation accelerated in the 20th century and hardwood supplies became increasingly expensive and environmentally damaging, scientists and engineers began searching for alternatives. They discovered that bamboo fibers, when processed correctly, have extraordinary tensile strength, comparable to steel on a weight-to-weight basis. The challenge was not strength. The challenge was control. Natural bamboo is hollow, round, and irregular. To compete with hardwood, it needed to be reshaped, stabilized, and standardized. That challenge gave birth to the modern engineered bamboo wood industry. Today, bamboo wood is no longer handcrafted in small workshops. It is produced inside supergiant factories, operating with precision machinery, high-pressure presses, chemical treatments, and strict quality control systems. The journey begins in the bamboo forests. Unlike trees, bamboo is harvested at peak maturity after just 4 to 6 years. Once cut, the root system remains alive underground. New shoots grow naturally, without replanting. Some bamboo species can grow over 1 meter per day, making bamboo one of the fastest renewing raw materials on Earth. This regenerative cycle allows continuous harvesting without deforestation. Harvested bamboo poles are transported to processing facilities, where the transformation begins immediately. Inside the factory, the bamboo is cut into precise lengths, then split open lengthwise. The outer skin, inner pith, and nodes are removed. What remains are long, flat bamboo strips, the foundation of bamboo wood. But raw bamboo strips are not yet durable. Bamboo naturally contains sugars and starches that attract insects and cause rot. To solve this, the strips undergo intensive treatment. They are soaked or pressure-treated in mineral-based solutions such as borax and boric acid, or exposed to high-temperature steam. This process removes sugars, kills insects, and stabilizes the fibers. Next comes drying. The treated bamboo strips are placed in large industrial drying kilns, where moisture content is reduced to around 8 to 12%, similar to hardwood lumber. This step is critical. Without proper drying, bamboo would warp, crack, or delaminate during later processing. Once dried, bamboo enters the heart of the factory, engineering and compression. Depending on the final product, bamboo is processed in different ways. In laminated bamboo production, strips are coated with industrial-grade adhesives and arranged in precise layers. They are stacked horizontally or vertically, then pressed under intense heat and pressure. The result is a solid bamboo board with uniform density and strength. In strand-woven bamboo production, the process goes even further. Bamboo is shredded into fibers, mixed with resin, and compressed at extremely high pressure. This process collapses the natural fiber structure and locks it into an ultra-dense form. The resulting material is so strong that it often exceeds the hardness of oak, maple, and even some engineered hardwoods. This is where bamboo stops being a plant and becomes an engineered material. The pressed bamboo blocks are cooled, stabilized, and cut into boards. These boards are then machined with extreme precision. Automated saws trim them to size. CNC machines shape edges and profiles. Surfaces are sanded smooth. Protective finishes are applied to enhance durability and moisture resistance. At this stage, bamboo wood becomes indistinguishable from traditional lumber, except for one crucial difference: performance. Engineered bamboo wood is highly resistant to warping, shrinking, and cracking. Its strength-to-weight ratio is exceptional. It handles humidity changes better than many hardwoods. It resists wear, making it ideal for flooring, furniture, wall panels, staircases, doors, and structural components. In large bamboo factories, production never stops. Conveyor systems move materials between stations. Presses operate around the clock. Quality control scanners inspect density and alignment. Each board is tested for strength, moisture, and consistency. Only boards that meet strict standards move forward. The scale is enormous. Supergiant bamboo factories process thousands of tons of bamboo every day, producing flooring for millions of homes, furniture for global markets, and building materials shipped worldwide. Entire residential developments now use bamboo as a primary material. The environmental impact is profound. Bamboo absorbs large amounts of carbon dioxide as it grows. Its rapid regeneration allows continuous harvesting without clear-cutting forests. Compared to hardwood production, bamboo manufacturing dramatically reduces land use, water consumption, and carbon emissions. This makes bamboo wood one of the most sustainable construction materials available today. But bamboo wood is not just about sustainability, it is about industrial performance. Modern architecture demands materials that are strong, stable, uniform, and scalable. Bamboo meets these demands. Engineers now design bamboo beams, panels, and hybrid structures for commercial buildings, bridges, and modular housing. What once grew wild along riverbanks is now shaping the future of cities. Behind this transformation is a massive global industry, combining agriculture, material science, industrial engineering, and green manufacturing. Bamboo wood factories represent a new generation of industry, where renewable resources replace finite ones, and waste is minimized at every stage. If you enjoyed this journey into one of the most important green industries on Earth, make sure to like, subscribe, and turn on the notification bell. We'll continue taking you inside the mega factories and hidden systems, transforming natural resources into the backbone of tomorrow's world. Thanks for watching, and stay curious. Every 3 years, America's giant willow fields explode into activity. Massive machines sweep across the landscape, slicing entire rows of shrubs in seconds, shredding them into biomass fuel, and sending them into processing plants where they're transformed into clean, renewable energy. What used to be a forgotten species is now becoming one of America's most promising climate solutions. Today, we're going inside a harvest like no other. Where trees grow like crops, machines cut entire forests in hours, and science brings new life to sustainable energy. Welcome to the supergiant willow harvest. Before we begin, remember to like, subscribe, and turn on the bell, because you won't want to miss what comes next. Why willow? Because it can grow 8 to 12 feet in a single season. reach full harvest size in 3 years, and then regrow from its own stump. That means a single planting can be harvested 7 or 8 times, producing biomass for 20 years. No replanting, no reseeding, just a cycle of growth, harvest, regrowth, and more harvests. Willow is the perfect climate crop. Its deep roots hold soil in place, preventing erosion. It absorbs large amounts of carbon dioxide, up to 10 tons per hectare per year. It requires no fertilizer once established and minimal irrigation. And unlike corn or soy, willow can grow on land considered too poor for food crops. Farmers call it the tree that grows where nothing else wants to. And because it regenerates from its base, willow can be cut to the ground and come back even stronger, like a perennial grass, but made of wood. This remarkable feature is what makes the giant willow harvest possible, a harvest where forests grow like fields and trees behave like renewable fuel plants. And now it's time to step into the fields, where the magic happens. Unlike regular tree nurseries that grow saplings, willow plantations begin with cuttings, pieces of stem taken from a healthy willow parent. These cuttings, usually 8 to 10 inches long, are collected in winter when the trees are dormant. Each cutting contains enough stored energy to sprout roots and leaves once spring arrives. Farmers use a machine that looks a bit like a corn planter, except it feeds cuttings into the soil vertically. As the machine moves forward, it pushes each cutting into the ground exactly 8 inches deep and exactly 2 feet apart. Willow fields are planted in long, uniform rows with tight spacing that maximizes biomass. 6,000 to 7,000 stems per acre. Once planted, willow grows explosively. In the first year, stems reach 4 to 6 feet. In year 2, they shoot up even faster. By the 3rd year, a dense forest of slender stems, each about 2 inches thick, stands ready for harvest. These willow plantations don't look like typical forests. The stems are thin and flexible, swaying like giant grass in the wind. But while they seem delicate, they hold enormous energy potential. Each acre can produce 5 to 10 tons of dry biomass per harvest, enough to heat homes, generate electricity, or be turned into biofuels and pellets. During the growth period, willow requires almost no maintenance. Farmers may mow between rows to control weeds, but the trees themselves grow with little help. No fertilizer, no pesticides, and no irrigation, just sunlight, rain, and time. But the real magic comes after the harvest, because unlike other energy crops, willow doesn't die. When cut, each stump, called a stool, responds by sending up a burst of new shoots. Within weeks, green stems emerge again, beginning a new 3-year cycle. This regenerative ability means the same field can be harvested repeatedly for decades. It's one of nature's most efficient, renewable systems. A tree designed not for lumber, but for endless cycles of clean biomass. And now comes the most spectacular moment, when the machines arrive. When the 3rd autumn arrives, willow farmers prepare for a harvest unlike anything in traditional agriculture. The machines used here are immense. Hybrid harvesters adapted from European forage harvesters used in corn and sugarcane fields. But instead of cutting grass, these machines cut entire rows of trees. The star of the harvest is the cut and chip harvester. It moves through the field with a deep, mechanical roar. Its forward blades slicing through thousands of willow stems at the base. As the stems fall, powerful rollers pull them inside the machine, where rotating knives instantly shred the wood into small chips. Imagine cutting down a forest and processing it into fuel, all in one pass, all in real time. The chips flow through a chute and into a tractor trailer driving beside the harvester. Every few minutes, the trailer fills with steaming, freshly cut willow chips. The tractors rotate like clockwork, switching out full trailers for empty ones without stopping the harvester. The entire operation moves like a factory on wheels. A single machine can harvest 20 to 30 tons of willow per hour. Entire fields that took 3 years to grow can be harvested in just a day or two. From above, drones capture the breathtaking movement. Long straight rows collapsing and disappearing behind the harvester, leaving clean-cut stumps that will sprout again in spring. The willow harvest is unique in agriculture because the crop regenerates. No plowing, no reseeding, no tilling, just pure renewable growth. But the chips aren't useful in raw form. They must go through a giant processing system to become usable fuel. And that brings us to the next phase of this incredible journey. Once harvested, willow chips are transported to large biomass processing centers. These plants look a bit like lumber mills, but their purpose is very different. Instead of making boards or furniture, these factories turn wood into fuel. First, the willow chips are dried. Freshly harvested willow contains up to 50% moisture, too wet for efficient burning. The chips are placed inside giant drying drums, rotating cylinders heated with low-temperature waste heat from nearby industrial plants. As the chips tumble, warm air removes excess moisture and reduces the weight by half. Once dried to 15 to 20% moisture, the chips are screened. Oversized chunks are rechipped. Dust and bark particles are separated and used as soil amendments or compost. Next comes pelleting, a step that compresses the chips into dense cylinders. The dried willow enters a pellet mill, where it is squeezed through small holes at high pressure. The heat from compression binds the natural lignin inside the wood, forming smooth, shiny pellets with no chemicals or glue. These pellets are packaged into bags for home heating, stored in bulk for biomass power plants, or transported to industrial boilers. Because willow burns cleanly and consistently, it's ideal for energy production. Some facilities don't pelletize the willow at all. In upstate New York, entire communities receive clean energy from willow-fueled plants. Even the leftovers from processing, dust, fibers, and bark, are composted or used to restore soil health on nearby farms. Nothing goes to waste. If you enjoyed this journey through America's renewable energy forests, make sure to like, subscribe, and turn on the bell. Because we have many more incredible stories coming your way. Stories of nature, stories of industry, stories of how everyday materials are grown, harvested, processed, and transformed into the world we rely on. In this video, we'll step inside the supergiant plywood industry, exploring how raw logs are stripped, peeled, dried, layered, glued, pressed, and finally cut into the panels that shape our world. We'll also uncover the history of plywood, from its humble beginnings in ancient Egypt to the mega factories of today. So buckle up, because this is the epic process of how layers of wood become strong boards, in one of the most fascinating industries you've probably never seen. Long before giant factories and high-speed machines, the idea of layering thin sheets of wood to make something stronger was born. Historians trace plywood's roots all the way back to ancient Egypt, around 3,000 years ago. Egyptian craftsmen glued thin veneers of precious wood onto cheaper materials to create durable furniture that looked beautiful, but didn't require massive solid logs. The concept resurfaced in 18th century Europe, where fine furniture makers experimented with thin layers of veneer for both aesthetics and strength. But plywood as we know it truly took off during the Industrial Revolution. In 1865, Emmanuel Nobel, father of Alfred Nobel, who later created the Nobel Prize, invented a rotary lathe to peel thin sheets from logs. This innovation changed everything, making plywood affordable and scalable. By the early 20th century, America embraced plywood for construction. During World War II, it became a critical material for military airplanes, boats, and barracks. Strong yet lightweight, plywood proved to be a miracle product. After the war, the housing boom in the U.S. accelerated demand, and plywood became a staple for walls, flooring, and roofs. Today, the global plywood industry produces over 100 million cubic meters annually. Mega factories across the US, China, and Europe can each churn out thousands of boards per day, feeding construction, furniture, and even shipbuilding industries. What started as an ancient craft is now one of the most powerful industries shaping modern life. The plywood story begins deep in the forest. The primary raw material, softwood and hardwood logs. Often Douglas fir, pine, poplar, or birch. These trees are carefully selected, harvested, and transported to factories in massive trucks. Once the logs arrive, they go through the debarking process. Giant machines strip away the rough outer bark, exposing the smooth wood beneath. The logs are then cut to specific lengths depending on the type of plywood being produced. But here's a fascinating part. Before peeling, the logs are often steamed or soaked in hot water. Why? Because softening the wood makes it easier to peel into thin sheets without cracks or breaks. Imagine trying to peel an apple. It's much easier when the skin is soft. This stage is all about preparation. Millions of logs enter these mega factories every year, and every single one is destined to be transformed into thin, flexible veneers, the building blocks of plywood. This is where the magic happens. The prepared log is mounted on a giant rotary lathe, which spins the log at high speed. As it rotates, a razor-sharp blade slices into the wood, peeling off continuous sheets of veneer, often as thin as 1/8 of an inch. It's almost like unrolling paper towels, except instead of soft tissue, it's solid wood being unwound like a ribbon. The sheets, called veneers, can stretch up to hundreds of feet in length before being cut down to size. The efficiency here is astonishing. A single log can be peeled into multiple sheets with minimal waste. Even the leftover cores are often used for other wood products or energy in the factory. Watching this process is hypnotic. A round log is turned into flat, flexible sheets in minutes. This technology, invented over 150 years ago, still powers the plywood industry today, but on a supergiant industrial scale. Freshly peeled veneers are still too wet to use. To become plywood, they must be dried to the right moisture content, usually between 6% and 10%. Factories use gigantic drying tunnels. Sheets are fed into continuous conveyor dryers, where hot air, often 180 degrees Celsius 356, circulates around them. Within minutes, veneers lose their excess moisture and come out flat, dry, and ready for gluing. But drying is a delicate balance. Too dry and veneers may crack. Too wet and they won't bond properly. Skilled operators and precise machines ensure that every sheet comes out in perfect condition. At this stage, the veneers are sorted. The best quality ones are chosen for the outer faces of plywood, while lower quality sheets may be used in the inner layers. Nothing goes to waste. Now comes the core of plywood's strength: layering. Each veneer sheet is coated with industrial adhesives, usually phenol formaldehyde resin for exterior-grade plywood or urea formaldehyde for interior use. These glues are incredibly strong and waterproof. The veneers are then stacked in alternating directions, each layer's grain running perpendicular to the one below. This crisscross pattern is the secret behind plywood's legendary strength. Unlike solid wood, which can warp or split, plywood distributes stress evenly across its layers. Factories often use 3-ply, 5-ply, 7-ply, or even 13-ply constructions, depending on the desired thickness and application. Each stack is carefully aligned before moving to the next stage, pressing. This is the most dramatic step. The glued veneer stacks are placed into massive hydraulic hot presses. These machines apply enormous pressure, sometimes up to 1200 psi, and high heat, often around 150 degrees Celsius, 300 degrees Fahrenheit. Under these conditions, the glue cures and the separate sheets fuse into one solid, durable board. It's a breathtaking transformation. Thin, fragile layers of wood become a panel strong enough to hold up a building. Modern mega-factories can press multiple stacks at once, producing hundreds of boards in a single cycle. Each press cycle may last only a few minutes, but the results are permanent, plywood that can last for decades. This step is where science and engineering meet. Without the hot press, plywood would just be a pile of veneers. With it, you get one of the toughest, most reliable materials in the construction world. Freshly pressed plywood doesn't look perfect yet. The edges are rough and the surfaces uneven. That's why the next stage involves trimming and sanding. In the US alone, millions of sheets are shipped daily, feeding the insatiable demand of the construction and furniture industries. Whether it's a suburban home, a school, or an office tower, chances are plywood from one of these mega factories is part of its structure. If you've enjoyed this journey inside the supergiant plywood industry and love discovering how the world's biggest factories work, don't forget to hit the subscribe button. Join our community for more mind-blowing stories of engineering, technology, and the industries that shape our lives.